I've invented a generator that generates excess electricity. Einstein said E equals mc squared. That is not correct. It's actually E equals m. Energy equals mass. For everywhere you have mass, you have atoms, and spinning around the atoms for eternity, as far as we know, are the electrons, which is the basis for electrical current with copper. Energy can neither be created nor destroyed, but it can be moved around. In all past inventions of this nature, people have failed to recognize that and tried to create energy. I am not creating energy, I'm moving it around. First of all, gravity had to be beaten at no cost. And not only beaten, but a new reality, because all of Newtonian's theories are totally, perfectly correct. All the laws of motion, laws of thermodynamics, perfect. I've created a new reality here by overcoming Earnsham's theorem of 1865 or 68, whatever it was, partly saying no permanent magnets cannot be used because in any form to get in any way to do any work, because it would be free, and with all the problems of moving around. Read Earnsham's theorem yourself if you want to. Well, I've overcome that by magnetic pressure. These are two positive poles in the center, if you see in here, one opposing the other, and it's floating. Then by the flywheel action overcomes all problems that Earnshaw states in his theorem. This works perfectly well. That is a frictionless bearing. The reason this doesn't go against any laws of physics is because this is now floating free of gravity, but it is still maintaining its mass, its weight. So it has torque. In outer space, I could spin this flywheel, it would spin forever. I could stop it just that, well, it has no momentum. Here, it's floating free of gravity. It centers itself on the axle in the middle there. It's frictionless, but it still maintains its weight. So bang. Here, the next thing with running a, and this setup, this is a much, the next part of a generator is that you can't overcome what is commonly known as load. That is, if you have a smaller electric motor running a generator, even the same size, it'll run all right. But when you put it under load, that is, get it to do work, you notice that what is the choking down of the generator, what is commonly known as load. What I found load to be is actually diamagnetism. When the copper is in proximity, the copper coils are in a generator are close in proximity with the magnet, they become diamagnetic. I have two flywheels here. This is a rare earth magnet. If you notice, it is floating also on, this is floating here, and then what is different in my invention is I have another magnet up here opposing, and this is all under pressure. This is magnetic pressure. So although it's floating, I'm able to hold it in place in the same situation. And okay. So the way that this works is over here. This is my copper coil used in a typical fashion. any normal generator. From this point on, it becomes just as any other generator. If this magnet were in a fixed position, as all generators are, when it would come around here, it would stop the entire machine, because it would be boom. It would put it when you put it under load. Instead of choking the machine down, the force of what the diamagnetism causes it to spin this in this direction, going past. A spinning magnet generates the same amount, or causes enough electrons to flow, as a fixed magnet. All right. And this is a typical copper coil. Puts out AC. It puts out AC. Then I'm converting it to a typical way down here into DC power, coming over here, and this is wired into my electric motor. At this point, the coil, being converted to DC, is hooked up to the electric motor. Therefore, it's under load. It's doing work. And as you can see, this electric motor is much smaller than the generator that's working. At this point, right here, that one coil is moving electrons through the system, through the motor, powering the generator, under load, and there you have it. I could put 4 more magnets, 2 more magnets, a bunch of more coils, but every time I get this thing going really fast, you're right. Right now, as you notice, it is under load and it is not choking down.